18 degrees is kind of the sweet spot. So the average cartridge is at 27. Okay, that's 9 degrees away. About 1 out of 9 cartridges I see don't meet manufacturer specs. More than 75% of the cartridges I see straight from the factory need to go back, unfortunately.
The Fidelity Exchange, pulling back the curtain on brands shaping high-end audio and more.
Hey everyone, welcome to the Fidelity Exchange. I'm Drew Baird from Moon Audio, and today I'm talking to J.R. Boisclair from WAM Engineering, who learned analog optimization from the legendary Wally and is now revolutionizing how we think about turntable setup. JR's research has revealed something shocking. The average cartridge is off by at least 9 degrees from optimal setup, which means almost no one has actually heard what their cartridge can do. If you're into vinyl and want to get every bit of performance from your system, make sure to hit that subscribe button. JR, thanks for joining me today.
Thanks for having me, Drew. I'm looking forward to this.
So take me back to the early 90s in Minneapolis. How did you meet Wally, and what was it like learning from the expert in analog?
I was introduced to Wally in the very early 90s by a fellow audiophile friend of mine who had him over at the same time I happened to be over at his house. And in him, I knew immediately this is somebody I can learn from. From all manners, not just analog, but I could tell he knew a good deal about acoustics and electrical impedances and electrical relationships as well. So I took an immediate draw to him. And so we built the friendship from there. I eventually ended up being his production assistant on a few of his products. And so some of the products he used to make were built by me, and he would pay me with equipment. So because he had all sorts of great audio equipment, and I do enough work, and eventually I had an LP12. It's just it was great for me, and I was learning all along the way. Yeah.
Very cool. Yeah, I mean, I had sort of a lot of the same beginnings in that. I used to trade, like I used to do it yourself, build speakers and modify equipment. And I was in all kinds of clubs where we met on Sundays to build stuff together. Yeah. And, like that, we sort of traded equipment instead of just buying new stuff. I got tired of something I built. I'd trade that to somebody and somebody would trade something they built. And so we get to, listen and hear and learn about the technology because, it wasn't something you built. Sometimes you don't always learn from your own creations, but much more from other people's creations.
Sure.
So I totally get it. What do you think was the most valuable thing that Wally taught you?
Oh, I can hear his voice in my head right now. Basics, basics, basics. Basic physics, basic geometry, basic mathematics. Never get away from that. I try to get too fancy and apply concepts that only maybe tangentially apply to what you're trying to do. You'll end up yourself in a bit of a mess. So you really focus on understanding basic physics, basic geometry. That was very important to him. Yeah.
So after his passing in 2008, what made you and Andre, his son, decide to revive WAM Engineering?
Yeah. Well, I was helping Andre when Wally passed away. I was helping Andre sort through his dad's estate and all the stuff he'd accumulated. Yeah. And almost as an afterthought, I said, hey, I know exactly how your dad made the tools that he did, and there's plenty that he left undone and unstudied. I said, do you want to be my partner, and we'll sell a couple of Wally tractors and Wally skaters? And he said, yeah, it'd be a great way to keep the memory of my dad alive and what he'd done so far for the industry. What I didn't anticipate is that as we would study the various setup parameters, how much has never been studied and how much we don't really know and how much has been wildly misunderstood. Yeah. Now, Andre Malowitz, I couldn't ask for a better partner. He's a very accomplished mechanical engineer. At the time, he was head of the largest research and development arm of Medtronics. So he had 200 engineers and scientists reporting to him. So if we needed, and we had all this equipment available to us as well. So, and still do, electron microscopy, infrared spectrometry, X-ray diffraction, and we started using it, finite element analysis, and so we put a lot of that to good use, and a lot of learning.
That stuff doesn't sound simple.
No, 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 no. But lots of great conversations. So he'd bring in some of his metallurgists in, and we'd have conversation. Or we'd bring in a finite element a finite element analysis expert, and so we'd have conversations about energy propagation through complex bodies. And the more I learn about mechanical transcription, and you're going to hear me use that term a lot because this is what this is, the more I realize how much we don't know. I mean, it's just, every time we look into a corner, we realize, oh God, behind that corner, there's a whole nother room that is influential to what we hear. Right. So we've got lots of experiments in our future, and we've been accumulating a lot of technical equipment lately to do just that. Yeah.
So what was one of the coolest pieces of gear he paid you with?
Oh, well, at the time I was pretty chuffed about the LP12.
LP12.
Let's see, some Woodside audio. Those are out of Britain. A set of monoblock tube amplifiers. God, I got a lot from him that over the years. I don't have a lot of it still at this point. I've since upgraded, but oh yeah, I could be doing what I do now without the foundation that he provided. Basics. Yeah.
And so you only thought you were going to sell a couple of Wally tractors a year. How did it grow into being one of the world leaders in analog optimization?
Because we did the work of studying what had not been previously understood by the industry. And this is, of course, after we belong to the AES, the Audio Engineering Society, and we scoured decades worth of research papers, some of which are great, some of which are riddled with errors. We spent a lot of time with that and with studying there. But it was just looking at the opportunities to better understand the medium. We just decided, let's do the work. Let's devise experiments. Let's collect data, and buy a very expensive microscope. Oh God! Right. And let's figure this out. We were just optimistic it would work out. I never thought it would be a full-time job for me.
Yeah.
But here it is. Yeah.
All right. So, I mean, let's get into the meats and potatoes of this topic, right? So let's talk about the bombshell, right? The average cartridge is 9 degrees off from optimal. Why has almost no one heard that that their cartridge's true potential because of this? And why, why do you think that turntable manufacturers don't do more in the way that they're setting up their arms and tables and so forth to account for this? You know what I mean?
Yeah. Okay. So first, let's just be specific what particular parameter you're talking about, because there are, and I did a video series about this. I got lots of educational videos on the website. You're referring specifically to vertical tracking angle, all right? Which is only relevant to stereo playback, not mono playback, right? Yes, on average, the average cartridge is about 9 degrees away from optimal. Yeah. How do we know that? Well, we've analyzed well over 700 cartridges here in the lab. We database all of them for what their vertical tracking angle is under stylus friction. And when you compare that angle to how lacquers are actually cut, whether they're using a Neumann SX68 or a Neumann 74 or a Redicut or a Audiophile or a Westrex, the highest vertical modulation angle, that is the cutter heads VTA, the highest you can get without wedging them further is about 25 degrees in some models. But the most all records today and throughout the stereo reproduction period were cut by Neumann cutter heads, and they're at 18 degrees. Okay, so if you and many of their competitors are even less than that. Okay, even less. So 18 degrees is kind of the sweet spot. So the average cartridge is at 27. Okay, that's 9 degrees away. Again, under stylus drag. Now this isn't actually new information. In 1964, there was a paper done you can go read it. It's on the AES website on vertical tracking angle, where they were studying what are the distortion characteristics inherent to this particular parameter. There are 7 parameters, by the way, for setup. This is just one of them. And during the study, they had a sample of 10 or 15 commercially available cartridges at the time. And they measured what are the VTAs of them, and then they studied the distortion characteristics of them. The very last paragraph of that white paper, they said, cartridge manufacturers on a whole would do very well to get that VTA down quite a bit. They are on a whole too high, and as a result, this cartridges are suffering more distortion than they necessarily need to. Okay, now let's address the last part of what you had asked for. You asked why would cartridge manufacturers not respond to this research that I just referred to? Yeah. 2 reasons. The first is that by raising the cantilever angle, they can get more magnetic material underneath the cantilever and still clear the record surface, and thereby increase the output of the cartridge, right? Yeah. That's one reason. But the second reason is, I believe, and I've confirmed this with a major cartridge manufacturer who happened to agree with me publicly twice, though I'm not sure I want to mention right now. You go on my website, you figure it out. Who agreed with the following. Cartridge manufacturers tend to unfairly get the blame for sibilance and mistracking. Mm-hmm. Okay? Now, I'm going to tell you kind of a story here, and it'll culminate to the reason you're looking for, the answer you're looking for. So most people think when they hear sibilance and mistracking, they think, well, and I think you probably know what that sounds like. It's pretty harsh. It's a breakup. It's a mechanical breakup. A lot of people respond by simply increasing the tracking force. Mm-hmm. That's the wrong thing to do. Mm-hmm. And I did a video on this. What's happening when you get that sibilance and mistracking, that mechanical sibilance, is that the stylus is momentarily leaving the surface of the groove wall and slamming into it. Okay? Right. And in order for the stylus to do that, assuming your tracking force is in the proper range, in order for the stylus to do that, it requires the tone arm to be under a torque force, pushing it one way or the other. Or it requires the tone arm to have a lot of friction in the bearing, where it just doesn't want to come along for the ride. Right. But most people don't use a Wally skater to measure these things. That's why the Wally skaters are our most important tool. Okay? And it's usually torque force, unmanaged torque force, or unmanaged friction in the bearings that is the major contributor to a cartridge declining its performance. Now, if torque force, and most people aren't managing it in their arm because they're not measuring it, if torque force is a primary contributor to sibilance and mistracking, not cartridge setup generally, just tone arm setup, then you might ask, well, what does this have to do with the cartridge manufacturers and the high VTA? This is the reason. As you raise the VTA, you increase the downward vector forces that help assist maintain contact between the stylus and the groove wall. In other words, as you raise the cantilever angle, you are employing more of the effective mass of the arm in the effort to keep it in contact. Right. And as you raise it, you're employing more and more. Just imagine a cantilever like this. Now, in order to get the stylus to lose contact with the groove, not only do you have to overcome the 2 grams of force in the tracking force, but you also need to overcome the 15 grams of effective mass of the arm. Mm-hmm. And that's less true as you bring it down, bring it down, bring it down. So it's a cheat. It's a cheat by the cartridge manufacturers to help avoid the criticism that doesn't actually belong to them. And if users would manage the horizontal forces and measure the friction in the bearings, they would not only get better sound, but it would put the cartridge manufacturers in a better position to say, okay, we'll come down. You as a population have gotten it now, we'll bring it down. Now, I don't think there's plenty of cartridge manufacturers who I believe are not explicitly aware of what I just told you, right? And some of the companies that make cartridges on an OEM basis, like XL Sound Company out of Japan, which do a great job, by the way, their jigs and their tooling is set for a specific insertion angle, and that they're not changing it.
Yeah.
Not without pressure from the industry. So that's just one parameter. I think I answered your question.
Yeah, and I mean, something else that I'm sure a lot of people don't think about, and it's probably not so fair to put it all on the cartridge, right? Because you've got an arm that you can raise and lower and whatnot, and that's going to change the angle, right? And you're going to try and balance it. And then you've got arms that have different weights. I mean, I think you said that, the heavier the arm weight, the better versus a light one, even if they're both equally balanced. Would you say that would be true as well?
And I did a video about this. I'm a huge proponent of high effective mass, but the devil's in the details. You've got to have your house in order. I mean, if you're not controlling that arm, it's going to make things worse for you. If you play lots of warps with your records, it's going to make things worse for you, right? So and with regards to raising and lowering the arm to impact VTA, I would love it if we stop referring to raising and lowering the arm as changing VTA.
Yeah.
Technically it does, yes. When you raise and lower the arm, you change VTA, but that's not what we hear at all. What we hear when we change and lower the arm are multiple vector forces changing, multiple. And that's why people think that when I raise and lower the arm, there's a tonal characteristic to it. Many people say, well, when I lower the arm, the bass becomes heavier and then eventually becomes too muddy. Or when I raise it, the treble becomes more forward and the bass leans out. That's not what changing VTA sounds like at all. The VTA should be changed at the head shell. Right. Independent of those vector forces. Sorry, I don't know. You want me to go into the lessons or not? Those are new videos and all this stuff.
I mean, the arm. I think the arm plays really a big a part of this, and if we can't, I don't think we can blame it all on the cartridge itself. I mean, definitely there's some faults there, but I mean, and then it also it comes down to whether a person wants to take the time to really get into setting up the turntable properly, right? And one thing I also noticed, I got to do a bunch of your videos this weekend, and I got the tractor here and the skater. I haven't gotten to the skater yet, so I did the tractor first, right? Because actually, when I got done setting up everything with the tractor, then I had a customer say, hey, the cartridge that I set up on that turntable at home, he wants to hear it. And so now I have to take it off that turntable, bring it in the office, and start from scratch on a different table. So I didn't get to the skater yet. But one thing that, and this is probably a question for myself, but it'll probably help some people too. You talked about doing everything in terms of, weighing the cartridge, setting up all of the everything that we do with the tractor with just the platter or just using a record, not using, a lot of people are putting cork between the record and their platter, and all of these things are going to change things after they've used your tools, right? So do you try and tell people to stay away from putting, the cork and the felt and all this stuff on the platter and just do the record straight on the platter? Or does that minute amount really make a difference after you've done all this setup without that stuff? How does that screw things up? You know what I mean? Because now you've got guys that are selling these different, felts and whatnot that are saying, oh, this is improving the sound because it's changing the dampening and the vibrations and stuff like that. But, we're setting all of this stuff up without it, and then you put this on there, and how does that affect the elevation? How does that come into all this?
Oh, okay. So there's really two questions in there as far as I see. One is the question of what do you think generally about playback using differentiated mats? And then the other is the question of what role does having the mat whilst using the tools in the setup play at all? Well, okay, first of all, the typical mat, it takes VTA and SRA are actually pretty insensitive parameters to the ear. The distortion characteristics that they throw off are pretty insensitive to angular deviation, unlike zenith error, which we can talk about later, unlike azimuth, which we can talk about later. So if your mat is, say, 2 millimeters thick, let's say, right? On a 9-inch arm, that's a half a degree on VTA and SRA. I'm not going to get bent out of shape about that for SRA and VTA. That's half a degree is a big deal on azimuth, and it's audible on zenith error correction. Okay, so we got to put that into perspective first. On on some of the tools like the Wally skater, we say, yeah, if you remove the whole point of the Wally skater is that you're measuring horizontal torque forces as a percentage of your tracking force. Okay, and so with many arms, your tracking force will be different if the stylus is at this altitude or that altitude or this altitude. That has to do with the center of gravity of the arm. I won't go into that. So that's why with the Wally skater we say put the stylus 2 to 3 millimeters above the platter. What I really mean by that is put it at record height. Now, if you've got a 2 millimeter thick platter, you can, mat,
Right.
you can remove the mat and add that thickness to that 2 to 3 millimeters I tell you to do. So now you've got greater clearance. Now, instead of 2 to 3 millimeters off of the platter to account for the record, you're closer to, 4 or 5 millimeters. Just give you extra cushion. With regards to changing mats, there's the biggest sonic differentiator, I believe, that what we're hearing when we do that is related to the mechanical impedance of the record with whatever it's touching. So when you drag a stylus through record, you are mechanically exciting that record. We know that there's been at least 2 studies on this in different ways that you're actually vibrating the record. The record is vibrating. Right. That's not good because we don't want those vibrations to ripple, reflect off of something, come back to the stylus, and then modulate the stylus, right? Because while that would be correlated noise, it's still noise, okay? And correlated noise is less problematic than uncorrelated noise. But so what the mats do is they vary the mechanical impedance. So a soft mat, however, relies on doing some damping characteristics to drain that energy out. I don't think that that's optimal. Because what that means is that, yes, some of the mechanical energy of the record vibrating will be turned into heat into the mat, but it takes time to do that, and the record will continue to vibrate over that time. If rather we can perfectly couple the record to another material that has similar mechanical impedance characteristics, then that vibrational energy will go into that material, go away, propagate away from the precious stylus, and dissipate elsewhere, right? Now that doesn't mean that you're going to have bad sound if you put a mat on. That's not what I'm implying. I spend a lot of time talking about optimal conditions. It's not easy to get into optimal conditions, right? Yeah. There's a lot of things to attend to. Did I answer your question?
Yeah.
Okay.
How about explaining to everybody more about, what zenith and azimuth, correlate to and how they're important and all that stuff?
Okay, so azimuth, if you're looking at the cartridge from the front, right? Mm-hmm. It's this. It's like a listing ship, a list to port, list to starboard, right? Mm-hmm. Now, most people think, well, I want to get it level because the stylus needs to be perfectly upright in the groove. That's not true at all. Mm-hmm. Okay, first of all, let's back up. Why do we even adjust azimuth? It's to get maximum channel separation. We don't want right channel information bleeding through to the left channel and vice versa. Yeah. Let me show you a model. So this is a 1,000 to 1 scale model of a Japanese type stylus with a micro ridge edge. Mm-hmm. The parts of the stylus that actually touch the groove are right here near the tip, really close there. That's what actually touches the groove. There's a radius here, not a flat edge, a radius. And the purpose of the radius is to allow the stylus to be in the groove, wonky, and still scan the wall just fine. Right. Okay? Yep. I did a video with an animation showing why it's actually the coils we care about, not the stylus. And the only way to measure that is electrically. Now, zenith error, and we can show an image here, zenith error is a timing problem between the left and the right channels. Mm-hmm. The left contact edge of the stylus is reading the groove before the right channel contact edge of the stylus. Right. Now this is a linear distortion. It's a timing distortion, and as audiophiles, we're far more sensitive to timing errors than frequency errors. You can prove that out simply by doing a measurement at your listening position and see all the ragged waveform, right? We're very forgiving to frequency aberrations. We have a lot of problem with timing aberrations. But cartridges are made within tolerances. There's only 3 manufacturers in the world that make the stylus and cantilever assemblies for most all of the high-end audio cartridge makers. And they've got tolerances with which they will fit that stylus to that cantilever.
Yeah.
And I can show you some real disasters of very expensive cartridges that are up to 20 degrees off. Yeah. Now, you can still get sound that you enjoy from such a cartridge. But if you were to hear it, if I could magically flap my fingers and fix that problem, instantaneously you would hear the improvement.
Yeah. Now, what I haven't seen is, so, I understand how to get rid of the timing errors by, rotating the cartridge and using the Wally tractor to get everything aligned and whatnot. But how do you, when the cartridge, the arm should be in the right angle, and your head shell you would think would be in the right angle. How do you deal with the left and right, angles of dealing with?
You're talking about azimuth, back to azimuth, right?
Exactly. How do you correct for those on a tone arm and a cartridge? It's not an easy thing to do, really.
So most tone arms have an azimuth correction mechanism. All right. Some do not, like Rega. Rega does not, and some of the other British brands. They eschew this parameter in favor of greater rigidity for the arm. And while it is true that if you offer an azimuth adjustment mechanism, it will be by necessity a reduction in rigidity. Yeah. I know how much there is to be made up for in crosstalk correction with the average cartridge, and for me the juice is not worth the squeeze. I want that crosstalk correction. Right. And so for those people who do have a Rega and send their cartridge to me for analysis, I always have them put one of the Wally reference tools, this one, on their head shell to measure how far is the head shell off from being level to the platter. And almost always there's something for me to make up for. So let's say if it's 0.4 degrees clockwise in error, I can put that into the corrective shim. I had even this morning, somebody sent me an image of, they'd put the Wally reference, the main unit, which is called the dual axis right here, put it on his head shell to level the underside of the head shell to the platter. And you could see that the arm wand was like this. But the head shell was level. Right. What's that tell you? The head shell and the arm wand are not parallel with each other at all. Yeah. This is actually common in some models, right? So ideally, we've got them collinear or parallel with each other, but this is rather frequent. Yeah.
That's interesting. I don't think I've seen. I mean, I haven't owned a million turntables, but I haven't seen that where the angles are different on both of those. But
yeah, well, you put a tool like that on enough of your arm,
and it might be so small that you can't see it. Yeah, so you can make shims that can correct in both directions, right?
Yeah,
front to back and sideways as well. That's interesting. Right. I mean, is your library available to people? I don't know if I saw this on your website. All the cartridges that you already have measured, are they available to find out? Which need. Obviously, your turntable is going to come into play here, but which ones sort of need help in rescuing, if you will, right?
No, I don't make my database public, as I don't want to. I need to put that into perspective. Okay.
It may cause more harm than good if they don't do the right thing, right?
Yeah. So let me. It's a valid question, JR. Why don't you share the information with us? And I have people ask me this, and I will give them an answer. I'll tell them who are the brands that tend to have less error, but I put this in perspective. I say, look, and I did a video on this. Cartridge alignment isn't everything, right? There are many other design considerations that go into the make and build of a cartridge that will influence its eventual sound. So what we do, we just optimize what's already been made. So let's just say brand like Audiophile does a pretty good job. Okay, uh, with the exception of VTA, which is basically all of their peers as well. Right?
So actually, the cartridge that I just put on this weekend and took off this weekend is actually their credenza bronze, just so you're aware of.
Yeah,
So
yeah,
I'm playing around with that one.
They tend to have less error
Yeah.
than many of their competitors. However, that doesn't mean that they're going to be the best sounding.
Exactly.
Okay. Okay. I mean, they're very competently designed and built cartridges. Don't get me wrong, but that doesn't like some of my favorite cartridges are riddled. I've seen enough of them, over 100, are riddled with errors.
Right.
I like the sound of that cartridge best once optimized. I don't like the sound of them necessarily when they're unoptimized. They lose focus, clarity, right? But once they're dialed in, it's a different animal.
Yeah, that's an interesting. That just brought up something, a light bulb in my head. I've done a couple of videos on measurements and why measurement. My keywords to get people's attentions are measurements don't matter, because at the end of the day, the bottom line is, what sounds good to my ear, right? Mm-hmm. Tube amps are noisy. That doesn't mean they don't sound fantastic, right? I mean, so you can't always get hung up on measurements, right? Because even though that cartridge is, like you said, it's measured terribly, but you can optimize it just like you can optimize anything else in the audio world. So
that's right. That's right. So one other thing I would add to your position is that there's a lot we know we can hear, mm-hmm. but we don't understand how to measure it yet.
Yeah.
Okay, a lot, right? Like, how do you, and like resolution, right? Yeah. What we're doing as audiophiles, what we're constantly chasing is a lowering of the noise floor. Mm-hmm. And there are different aspects of noise. There's different ways to introduce noise: electrically, mechanically, acoustically, psychoacoustically. Yeah. But all noise isn't equally offensive to our ears. Correct. Like, for example, we've done enough experimentation across a number of people on many different systems. We know that the timing errors of zenith error are much more offensive to us than cantilever angular error, which is a different type of distortion. That's a nonlinear distortion. Zenith error is a linear distortion, nonlinear versus linear. And in that case, the linear distortion is much more offensive to our ears. That's the timing distortion, right? So I think that the whole industry, whether it's the cable industry, the electronics, there's a lot more for us to do to understand how to measure what we know we can hear, but we can't fully measure it. So while I would say I agree with you, I think if enough effort is put into this, eventually we will be able to measure more and more of those characteristics that will lead you to the path of what we know you like. And some people are going to have their biases. They're going to want extra mid-range bloom. Fine, you can have your biases, right? There's nothing wrong with that.
So now that we've got, everything optimized, the 4 angles dialed in, tone arm forces under control, what else do you think people should be focusing on in the turntable world?
Well, once you've nailed your setup, then you're going to enjoy it for a while. But I would look for future acquisitions that you make, to maybe a new tone arm or a cartridge or turntable. Some of the things, and I've started doing videos about this, that are important to take into account is mass and rigidity. Mm-hmm. In the mechanical transcription, mass and rigidity count for a huge deal. Yeah. Now, the devil's in the details, and it's just not it's not just hey, throw weight at it, let's put lead on it. No, lead's not rigid. Okay, and then if you do load it up with rigid, heavy items, well then you got to pay attention to your mechanical impedances. Once energy gets into that solid body, how does it drain away quickly without staying near that sensitive cartridge motor? The cartridge motor. Here's what we know. The cartridge motor, after it puts out its electro signal and it goes through all the amplification and reaches us audibly through the speakers or headphones, we know that as little as 7 nanometers of displacement is audible. Now, 7 nanometers is way below the wavelength of light. So smaller than, we're talking molecular size.
Right.
Okay, smaller than the most powerful optical microscope could ever see, right? Down to scanning electron microscope region. This is amplifiable. This is part of the low level signal that we appreciate. So that's the sensitivity of the system in the nanometer range. That tells us something about how careful we should be about managing how we transcribe that information and keep the system still.
Yeah.
The most important location in the whole turntable, by a long shot, is, here's the stylus, it's the most important location is the pivot point of the cantilever. Mm-hmm. We want that pivot point to remain immeasurably still.
Yeah.
Perfectly still, because that pivot point is surrounded by a magnetic field, and if just the pivot point moves like that, that's a signal. A signal is generated,
yep.
right?
Yeah.
But that's not what's in the groove.
Yeah.
Right?
Yeah.
So how do you still that?
Yeah.
Mass, rigidity, paying attention to mechanical impedance paths. Mm-hmm. Yeah. I recently had the most expensive cartridge this week. I had the most expensive cartridge in the world by a long shot to analyze. I've had 2 of them so far, but I didn't have time to listen to it the first time. $42,000 cartridge.
Ooh.
Right? Yeah.
Good Lord have mercy.
But I was excited about it when I saw the specs and what it was made from. Back
rare
when
earth minerals right there.
it's made from sapphire. The body, the joint tube, and the stylus cantilever is an integral piece, one piece of diamond. Okay, so there's no glue joint between the stylus and the cantilever. Ultimate rigidity. So and the material, we're talking sintered sapphire. It's harder than I think any ceramic, right? And sintered sapphire is different from monocrystalline sapphire, so it's not as hard as monocrystalline sapphire, but it's very rigid. So I was excited to hear this thing before I'd even got it. I was expecting to get great things. I wasn't expecting to want to listen to all of my records again. It was that much better. Now,
better
it's
be $42,000.
Well, $43,000 is an obscenity to many people.
Yeah.
And granted, I get it, but an investment was made by the manufacturer to invest in the most difficult to machine, difficult to manufacture, rigid items. What we see, and I think that it has, in my opinion, has delivered a window to what the future looks like. Okay. Now, if more manufacturers can get on board with this commitment to rigidity, then we can bring the cost down by finding new ways to get that characteristic into the system. So I get it's going to offend a lot of people to just have that. There's a number of people who can afford this kind of stuff, and they send me their cartridges. I get to hear any cartridge I want in the world, pretty much, as long as it comes through the lab. I'm very fortunate that way. That blew my mind.
Yeah,
it really did.
And how about some of the other elements of the cartridges? I mean, do you find that you like moving coil versus moving magnet, low voltage versus high voltage, or is it all just one more parameter to have fun with, or how does that stand in your court?
So I am definitely a moving coil guy, and for sure, that's my preference. I have heard fantastic sounding moving magnets. Yeah. There is a delicacy, a suppleness to low output moving coil that's pretty fantastic. But in order to get the most out of them, you need a fantastic phono stage too. Yeah. Now, I kind of like, my preference right now is in transimpedance gain phono stages, which amplify the current, not the voltage. And so the lower the output, I'm just speaking generally, the lower the output of the cartridge, the more gain you will get from a transimpedance stage. It's the type of circuit topology I prefer personally for phono stage favors that anyway. But the optical cartridges like DS Audio, they do a wonderful job too. But you know, different strokes for different folks, but
Yeah.
moving coil is where I am.
Yeah, we just started a new company called Saros Audio, where we're going to be coming out with a bunch of electronics. I don't know if you're aware. So we're both a retailer and a cable manufacturer. I started as a cable manufacturer first, and then I got tired of recommending to people what equipment to buy and so forth. So I started selling equipment as well. And
Yeah.
now I've just started a manufacturing company for doing electronics, and we're actually working on a tube phono stage, and so we're really getting into a lot of these aspects of cartridges and moving coil, moving magnet, low voltage, high voltage, and and I'm learning so much more from doing that about turntables, right? And how that sort of impacts what's going on in the phono stage. And then obviously, we've got our phono cables that, probably of all of the cables that we manufacture, those are sort of the most important in terms of the way you've got to be very sensitive to what's going on with that cartridge. And so shameless plug
yeah.
there on our Dragon cables. But anyway,
Yeah.
I mean, it's amazing how complex the turntable part of the system is compared to a lot of other pieces. I mean, I don't think people really understand how complex it really is.
I think many manufacturers of cartridges, tone arms, turntables don't understand how complex it is.
Yeah.
Because just in the design choices that they make, and then just kind of confound me, whilst they also believe that they are making something at the top tier. I'm thinking, no, that couldn't be. Those two things are diametric. Your design choice and optimal transcription are diametrically opposed, and I see that once in a while. And that's my opinion. Yeah.
So walk us through your cartridge analysis service. What exactly are you measuring, and what do clients get back from the measurements and so
Yeah.
forth?
So when we get a cartridge, it takes about I ask for 7 to 10 days to do the work. I inspect for zenith error, VTA and SRA, both of them under stylus drag, and optimal azimuth angle. I will, of course, make sure that the crosstalk is satisfactory within manufacturer's specs. About 1 out of 9 cartridges I see don't meet manufacturer specs. And some brands are worse than others.
Yeah.
Some of them more than 75% of the cartridges I see straight from the factory need to go back, unfortunately. Yeah, it's pretty bad. And only one time out of several hundred cartridges have I ever suggested the client do a warranty claim on SRA or VTA. Only once, because that cantilever angle is like 40 degrees. It's like, no way. No, it was more than that, 45. Most of the failures are in crosstalk being way below manufacturer spec, or zenith error being past the spec of the companies that they purchase the stylus cantilever assemblies from. But cartridge manufacturers don't measure zenith error, which is, by the way, more appropriately called stylus yaw, which that's exactly what we'll call it in our paper that we're currently writing for AES on the subject. Did I answer your question?
Yeah,
or did I take a side trip?
No, definitely.
Yeah, and so we measure those 4 angles, and then we make a corrective shim for you. And the corrective shim, the corrective shim that's included in the price of the analysis is a resin. It's a very rigid resin that we make from a rather expensive 3D printer. So that will correct for your SRI, VTA, and your azimuth. Now, we also mill brass shims. They are an upcharge, $275 extra, but they definitely sound better, for sure. There was a tracking angle review on that question. And now we're starting to mill austenitic stainless steel, which is really, really rigid stuff. Difficult to machine, but yet again, a little more clarity, a little more sense of focus and realism than even the brass.
So you've talked about you've done a bunch of videos. So where can folks check out those videos? And is there one video on your channel that's sort of the one they should go to get started? The get started video.
Yeah, so the best place to actually go is the website. Even though all the videos on YouTube, if you go to the website, you get guided through them, right? So on the main menu is the video menu, and then you've got a couple video pages to choose from. And the one that I want you to start with says, educational videos, start here. All right, and then it'll take you top down as you scroll down, right? I did a series of weekly videos, all about 5 minutes on average, all last year, 52 of them, on many different subjects. And I have those. Those are called the Soundbite series of videos, and those are indexed on a separate page. But that was really a lot of fun, and I got tons of great feedback from that. So yeah, I just encourage people, look, before you even buy any tools, just educate yourself. And if you think I got something wrong, look, I've been wrong before. In fact, in a couple of my videos, I correct myself. Right? There was a time I was wrong about something related to skating force. I've since corrected. I have no problem publicly stating my error. When the evidence is available, I got no pride about that. I only care about understanding the system better and better and better. So I'm sure there's something I think today that I'll have to correct in the future. Fine.
I will admit, I'm one of those guys that hates manuals and wants to just dive into stuff. And so I went to your YouTube channel first, and I was like, oh my God, I can't figure out where to start. I thought, I started with each one of the tools that I was using, but really you had to see stuff before that. So then I finally went back to the website and I figured out the correct order. But, you almost need to put a video on your YouTube channel that says, hey, go to the website first. That'll give you which direction.
Good idea.
Yeah, because for somebody that didn't, that came across your video on YouTube but hasn't necessarily been to your website yet, not that I'm saying your YouTube channel is confusing, but you don't know where to start on the YouTube channel. So I went backwards.
I feel you, and that's a very good idea. I will do that. Thank you.
So, where do you see analog optimization heading in the next 5 years? Is there something that people should be excited about?
Absolutely. Well, I did a seminar with Michael Fremer and some other manufacturers like Wilson, Benesch, and Audiophile and Dome Audio in Munich 2 seasons ago. And the title of the seminar was something on the order of, is vinyl gone as far as it can go? And my answer is an absolute resounding no way whatsoever. Yeah. As we've studied the playback side, we've had to go to the cutting room and understand the cutting side. So I've been working with cutting engineers in their labs from Greece, Germany, UK, and across the US to study how they do what they do. We cut our own lacquers, we cut our own records for our own research, right? The opportunities at the time of cutting to make better sounding records as well. So the future, I just see opportunity to get more and more out of the vinyl we already love. And so as far as the optimization, more specifically to the optimization, we are working on a tool I'm really excited about. It'll be called Wally Analytics, and the amount of analytical power, easy to understand, that the user will have to understand the behavior of their tone arm, their cartridge, and their turntable. Nothing has ever been done like this, and I just can't wait to release this thing. But it'll be iterative because there's many tests that we can make. So we'll release it with the first 1 or 2 tests, and then the more will come out. There's so much more opportunity to put the power at the user end, so that they can even avoid sending me cartridges to be analyzed in the lab. Ultimately, there's only so much of this I can do. I'm already stretched. So by the Wally Analytics is meant to take a little pressure off the lab and give you an opportunity to learn much more about the behavior of your turntable, tone arm, and your cartridge. That is useful information and actionable.
Well, I want everybody to know that, we're going to be using all of these Wally tools here at Moon Audio to be setting up cartridges and turntables for our customers. I've had a blast playing with the tools. They definitely make a huge difference. I can't wait to get into some of the other ones. I'll definitely have to send you some cartridges to analyze, and
I'd like you to experience that for yourself.
Yeah. That'll be fun to play around with. Go ahead.
Well, I don't know if I've ever heard when people tell me they want to send me a cartridge for analysis. I generally encourage them, listen to it on your own first, because I want you to understand the value of what you're getting when you get it back. right?
Yep.
So I don't believe I've ever heard, oh, I don't hear an improvement. I don't know
Yeah.
if I've ever heard
Yeah.
that. Um, but so yeah, I'm excited for you to hear
Yeah.
it.
Well, what we might also do here is, because we've got multiple of the same turntables set up here, is what we can do is, we'll get one of the cartridges we really love set up with one of those shims and measured out to the kilt, and then we'll set up another turntable with just basic setup, and we'll be able to go back and forth between the two real easily and have people, hear the differences. I
Yes.
mean, hearing's in the pudding. So,
Yep.
so one last question, when you were
Yeah.
listening to that $42,000 cartridge, what was the one song or track, piece of music that you just absolutely loved that you had to hear on there that just blew your mind?
Well, I'm a lover of the Royal Ballet by Answermet, conducted by Answermet. It's a yellow album with these. There's two ballerinas. Well, one ballerina. What's a male ballerina? Is it a male ballerina on the cover?
I don't even know.
Yeah, the valse by Tchaikovsky in the Swan Lake. It was just glorious, see-through presentation,
Yeah.
right? Just everything melted away. My walls melted away. The speakers melted away.
Yeah.
There is a sound, a characteristic sound to reducing the mechanical noise floor.
Yeah. Yeah.
And all of our efforts with the Wally tractor, the skater, the analysis is headed in that direction. And it's always the same audible characteristics you get more and more and more of: clarity, focus, separation of instruments, sense of realism versus the sense that you're listening to a stereo, right? And bass authority, bass tautness and detail. It's just more of that. And the fact that you start to just forgetting that you're listening to a stereo.
Yeah, I mean, I tell people all the time when setting up your system and when you get, digital and analog and all this stuff, the turntable is so critical in terms of what you do with dampening and how you place it and, getting it away from vibrations. And, I'm a structural engineer by original trade, and I can tell you all about vibrations
Yes.
and what they can do to massive structures. Well, just imagine what they can do to small structures.
Yes.
So, adding all kinds of dampening platforms and feet by isoacoustics and all that stuff. I mean, it really makes more of a difference with analog than anything else. So.
Definitely. Remember that little cartridge, 7 nanometer sensitivity.
That's insane. Yeah, absolutely insane. Well, JR, this has been great. Thank you so much for sharing your knowledge and challenging what we think we know about turntable setup. For everyone watching, if you want to finally hear what your cartridge is actually capable of, head to WAM Engineering's website. We'll drop the link in the description below so you can check it out. And make sure you know that we'll be using all of their tools to set up your cartridges and your turntables here at Moon Audio. And if you've enjoyed this conversation, make sure you subscribe to the channel, hit that notification bell so you don't miss the next episode. JR, thanks again for being here.
Thank you.
Any final words?
Now, this was fun. This was fun. Let's keep going down this course. I will guide you, like I do for anybody who owns Wally tools. Yeah. I'm available pretty much 7 days a week. I'll guide you on the path.
Fantastic. We'll see you guys next time on the Fidelity Exchange.
Cheers.